Sample problem 28.06. A straight horizontal length of a copper wire has a current I equal to 28 ampere through it. What are the magnitude and direction of the minimum magnetic field B vector needed to suspend the wire, that is to balance the gravitational force on it? The linear density, which is nothing but the mass per unit length of the wire, is 46.6 gram per meter. So in this questions, its related diagram is given here. So you have the wire which is coming out of the page, and this arrow, the upward arrows tells you, because you have to use the right hand rule. So when you just use the right hand rule, you will get all these details. So here the direction of the magnetic force is upward direction. So its upward opposite force is nothing but the force due to gravity. And right side we have the magnetic field. So in these questions we have to find the magnetic field direction as well as magnitude. So from this diagram, let's we write the direction of the magnetic field. The magnetic field is moving rightward direction. So now we have to use the rule for the magnetic force. The magnetic force rule FB, which is equal to ILB sine theta. So this is the rule for the magnetic force calculation. Now if you see the angle, when you are just using the right hand rule, here the angle exactly says theta is equal to 90 degree. So sine 90 becomes 1. So here you will get FB, which is equal to ILB only. Clear? Okay. The most important thing, the given information in the question is I equal to 28 ampere, and also they just gave the information about the linear density. Actually the linear density, generally we will denote the linear density with mu, which is equal to mass per unit length. So that means the mass per unit length value is given here as 46.6 gram per meter. So in terms of kilogram, which is 46.6 multiplied 10 power minus 3 kilogram per meter. Now after you apply the right hand rule, we got the theta is 90 degree. The most important thing, we have to balancing this magnetic force with gravitational force. So that means, so here in this diagram, FB, which is exactly equal to, that means the upward force which is equal to downward force based on this diagram. Actually this is the aerial view of the diagram. Okay, so here the wire is coming out of the page. When you are just using the right hand rule, you will get the direction of the magnetic force in this direction, and right side you have the magnetic field. So all these things you will get by using the right hand rule. Now here FB, which is equal to mg. So what I am going to do in this equation, in place of FB I am going to use mg. So mg, which is equal to ILB. Clear? Now we are going to find the magnetic field. So I have to rearrange this equation in terms of magnetic field. Therefore magnetic field B, which is equal to mg over I multiplied by L. And here the mass over length is nothing but the linear density. So in this place, how I can write? I can write this equation as m over L multiplied by G divided by I gives the magnetic field. Because why I just write the equation? Because both equations are exactly the same. So why I just write this equation like that? Because in this question they gave the information about the linear density mu value. They already gave as 46.6 gram per meter. So for that purpose I just rewrite this equation in this form. So by that the substitution of the values in this equation will be very easy. Clear? So that's the reason I rearrange this equation in this form. So now I'm going to substitute the value. So the linear density value is 46.6 multiply 10 power minus 3. 46.6 multiply 10 power minus 3, and the G value is 9.8 divided by the current value. I think they gave as 28 ampere, right? So 28 ampere for the current. So I have to substitute 28 here. So let's see what is the answer for the magnetic field. 46.6 10 power minus 3 multiplied by 9.8 divided by 28. Here I got the answer as 0.01631. So in terms of power, if you want to write, you can write this as B equal to 1.63 multiplied 10 power minus 2 Tesla. So this is the answer for this question. That's it. Thank you.